Welcome to this video on definite integrals. In our first example, we'll demonstrate how to enter a definite integral. In math mode, click the operators and go to the calculus section, and here we have the integral symbol. The tooltip tells us that we can use the shortcut Ctrl-Shift-I. In the integral template, there are 4 placeholders. 2 for the limits of the integration, 1 for the function of the expression, and 1 for the integration variable. A simple example. Let's say the integral from 1 to 2 of x squared dx. We can evaluate the integral numerically by pressing the equal sign, or symbolically. Let me take a copy and evaluate symbolically using the shortcut Ctrl-. In our next example, we'll look at the relationship between definite integrals and areas. In the example, we'll use a simple linear function, but the example will work with any non-negative function. The function here is 6 minus 6 divided by 5 times x. And we have the plot of the function below. We'll define the area function, a of x, equal the integral from 0 to x of f of x. This function will give us the area below the line in the interval from 0 to x. Let's calculate a of 2, and we can plot the area function. Let's take a copy here, place it here, and change this to a of x. We can evaluate the integral symbolically by pressing Ctrl-. Now let's see how it works with units. So let x have the unit meters, and we want f of x to have the unit meters as well. Then we must give 6 here the unit meter. And we must change the lower limit to 0 meters and 2 meters here. But it doesn't seem to work. In the symbolic calculation, the m is treated as a normal variable and not as a unit. So let's delete the symbolic result. Now the calculation works, but not the plots. The reason is that we can't use the standard range, so we have to define a range for x with units. And now everything seems to work. To make it work with the symbolic calculation, go to the Calculation tab. Choose the calculation options in the ribbon and select Units Constants in Symbolics. Recalculate the worksheet, press Calculate here, and you'll see everything works. M is blue, meaning that m is treated as a unit. In our final example, we'll take a look at a simply supported beam loaded with uniformly varying load, 0 at the left end and 30 kilonewtons per meter at the right end. The beam is 5 meters long, and W of x is the equation of the line. The 2 reaction forces are calculated. The shear function at x is defined as the reaction force at A minus the area of the triangle with base x. And we have made a symbolic evaluation with units and constants in Symbolics selected. The moment is the integral from 0 to x of the shear function. Now we can draw the graphs. Here we have the original function w of x, the shear function, and the moment. Thanks for watching.